Okay, hi again. So now we can actually start talking about power losses. So there are two types of power losses in our power electronic circuits. One are called conduction losses. So these are the losses that happens like when there's no switching, like when we have like passive and active switches, right? We have like switches, like many different types of switches in our circuits, right? Like these are gonna cause switching losses, which we're gonna discuss later. But the first thing I wanna talk about is conduction losses. Like, so when the current is not changing because of the switching, we still like have some losses that are called conduction losses. So we are gonna talk about this first, and then we are gonna see what the switching losses are. Okay, so the conduction losses that we're gonna study are related to four elements in our circuit. The first one is our transistor. The second one is the diode. The third one is the inductor. And the last one is the capacitor, right? So in our analysis so far, we assume that these are ideal devices, like, and we are operating them in ideal operation mode, like no internal resistance, nothing, right? So in practice, all of these have some losses because of the basically the resistances, internal resistances, like parasitic capacitance. There's many different internal losses that happens here. So like we have to model these losses somehow. So let's first start talking about the transistor, or the MOSFET transistor, for example. So I think you've seen in your electronic course that the current that goes through a transistor, it's basically like if it's BJT or MOSFET, it's something like this. It basically, the voltage of the drain source voltage or collector emitter voltage has to be bigger than something. Then we have some current, and then we get to the saturation mode. So this is something similar here, right? So this shows that this curve has a slope. It has two parts, right? One part which is linear here, and one part which is saturation, right? In your lab, many times Andrew mentioned that, oh, your transistor is saturated, right? So you have to basically change your input voltage, right? That's basically what's happening, right? We don't want to operate the transistor in the saturation mode, right? Because like then like there's no change in the current. So we're not using the transistor in its amplification mode. So this is basically the linear part. The slope of it, we call it I 1 over R ds on, right? Why is it 1 over? Because this is I with respect to V, right? So that's going to be reverse of resistance. It's called conductance, but this is reverse of resistance. The same thing here, like we have like 1 over R CE on, right? So this is a parameter that the manufacturer of the transistor should give us the information about it. So like should tell us like what that resistance is, what that on resistance is. So this is one thing about our transistors that we should know. So many times a transistor is modeled like a perfect switch. So like if you have something like this, many times it's modeled as a perfect switch with a series resistor, which is like this RDS on, right? So this is like how we model switches, so that like we can consider the losses in the switch, because this resistance is going to cause losses. So we are not talking about the losses that happens because of the switching. We're talking about the losses that happens when when this switch is already on, right? There are also like some losses that happens when you turn this on or off, right? That's something that we're going to discuss a little bit later. Right now we are going to talk about the losses that happens in this resistor. So that's one thing we should talk about. The second thing is the diode. So there are two types of losses that happens in the diode. Two types of losses. Like one is the conduction, one is the switching. Right now we're going to talk about conduction losses. If you remember, we talked about the characteristic of a diode, like IV, and something that like we want is like to have zero current when the voltage is negative and infinite current when the voltage, or any current that we want when the voltage is positive. In practice, this is not the case. We have something maybe like this. It's not a perfect curve, but basically this is the characteristic of a diode. It's usually the eye of diode. I think you've seen this in your electronic course, but it's like it's a exponential term, right? So like this is like how the current of the diode, it's going to change with the voltage, right? So in practice it's like that. We don't want to deal with this exponential term. So like when we model this, we model it like this. Let me do it with another color. So we model it like this. We model it like this, and then a line. Okay, this one is the forward bias voltage of the diode, right? Usually 0.71, 0.4, like depending on the diode that you use. And this one also, like you can see that this line has a slope, right? So the slope of this is like 1 over RD on. Okay, so when we want to calculate the losses of a diode, we basically model the diode like this. We have a forward bias voltage, and we also have, let me call it R of forward bias, RFD, or just like VF RF, right? And then that's it, right? You can also like add a switch here. But basically now the losses that we want to model for the diode, it has two parts. This is what I wanted to mention. Even the conduction losses, one is due to this one, because when the current goes through this, like you have a power loss which is P equal to VI, and you have another loss here which is going to be RI squared, right? So for